Hello everyone, today we'll be taking a look at the Caret package in R. Caret is an important and useful machine learning package in R. In this video, we'll be covering an introduction to Caret, machine learning with Caret, and a sample code using Caret as our package for R. So, it was developed by Max Kuhn along with a collaborative community. It provides an efficient way to implement the machine learning workflow, starting from pre-processing data to transform the dataset into a more usable form. Caret paves the way into efficient model training by allowing hyperparameter tuning and visualizing model comparisons for better understanding of our trained models. It assists in feature selection by analyzing the feature importances in our dataset. So this is a workflow that the Caret package follows in order to develop our models.
Caret has many versatile applications in machine learning. Namely, we can apply it to various use cases ranging from linear regression to neural networks. Now let's deep dive into each one of them and see how we can implement that for a particular dataset. For our sample code, we'll take the two most basic datasets available in R, which is the iris dataset and the empty cars dataset. Do a small tweak in my iris dataset to convert the multi-class classification into binary problem because GLM in logistic regression does not support multi-class classification. After this pre-processing, we'll first split the data into train and test. For this, we'll use the library CA tools available in R. Using this, we'll provide the split ratio available as 0.8, which will convert 80% data into train and the rest into test. This is available in first and the second parameters of this train test split. After our pre-processing of data, let's try to fit a linear regression onto this. If you see here, this code is as simple as this. We majorly use two parameters. First is the train and second is the method that you're passing into it. In your train, you're first predicting this value, which is the target value, miles per gallon, using these parameters. First is the horsepower, second is the weight, number of gears, and the engine displacement. We're passing the empty cars dataset onto this. Along with that, I'm setting the method as LM, which is a linear regression. Simply passing this method as LM is going to fit a linear regression onto this. To get a summary of this model, we can do summary LM model, which will give us all the data from residuals, coefficients, and also the significance of each weight. Now let's try to fit a logistic regression onto this. There's a very simple change wherein we just change the method to GLM. This is how Caret makes it versatile. By just simply changing the method, we can implement different models onto the same dataset. Now here we'll use the iris dataset where we are predicting the target value based on sepal length and the petal length. We will pass additional parameter family here, which is a binomial value. To get a summary of this model, we can use summary of GLM model, which will give us the in-depth analysis of logistic regression. The decision tree onto our empty cast dataset will pass the method as rpart. The major difference between rpart in R versus the one in Caret is that rpart does some custom hyperparameter tuning by default. If you check the results that we get here, we are trying for different values of cost parameter. We start at 0.0, 0.3 and 0.63. It evaluates the R squared value and other parameters and then it chooses the final value as 0.316. So this is some custom hyperparameter which is done by default. Another interesting feature in Caret is that we can plot this decision tree very easily. If you see, we are just importing this library rpart.plot and then we are plotting this decision tree. Similarly, we can use for random forest by setting the method as ranger. Another interesting feature is you can define some custom cross validation in Caret. Here the major two parameters are train control and the TR control. In your train control, you mention the method CV you want to implement and the number of validations that you want to do. And then you pass this parameter onto our TR control in train. It's as simple as that. If you see, your performance is increased after doing custom cross validation. Next comes hyperparameter tuning. On top of the custom hyperparameter tuning which is already there in our random forest, we can do some custom parameter tuning for node size and split rule. If you see here, we are passing the tune grid method in which we are passing this data frame where we are giving custom values for mtry, min node size and split rule. Based upon these values, it will do some parameter search and then we'll get our final parameters. Based on these values, we'll choose some final parameter which best suits our model. Last but not the least, predicting the test values. Here, we'll just simply call this predict method on top of our models which are already there. One interesting thing here is you can compare two different models by simply plotting them. If you see here, we are doing a comparative plot of random forest and XGBoost by simply writing this piece of code. Isn't that interesting? If you want all the things that you want to do on your machine learning model, right from pre-processing to model comparison, using Caret, these are the list of methods that you can use. This is a brief summary.